Hello. Today I want to find out what the real beta values of such a BC547 transistor are. And so for this test of beta of such a transistor, we make a setup and such. Then we put the transistor in here. We put 5 volt to its collector and also 5 volt to the base. But there is a resistor or base here, and through this resistor there will be current flowing into the base, and then because of the small current into the base there will be a bigger current through the collector up here. And what we will do is we'll vary these resistors here, and then we'll see with what type of current, what amount of collector current we get here. So we measure IB, the current into the base. We'll put a digital multimeter here to know what that current is. We measure the collector current with another digital multimeter, and then we can calculate the beta at that base current when we divide the collector current through the base current. That's the definition of beta. And to get different base currents I beta, we vary, as I said, the resistor R base here. And the values we choose for our base is we go from the high value 470 kilo ohms, which will lead us to around 9 microamperes as a base current, all the way down to 10 kilo ohm, which will perhaps lead us to around 8 milliamperes at the base current. And then we'll draw all the values down, and we see how the beta varies for these transistors with varying base currents. So let's do it. So the setup is ready. We have here the 470K resistor, so that's the first resistor we want to test. And I have not yet applied 5 volts to the base, but we'll do this now. And we see that we get for 407 kilo ohms, we get 9.3 microampere, 9.3 microampere, and 6.1 milliampere. 6.1 milliampere. Yeah, and then we'll go on with the next resistor value, which is 450. So 450K yields 9.7 microampere and 6.4 milliampere at the collector. And since this is pretty boring, I will do this on my own and then come back to you once we have all the values. So we are done with measuring. As you can see, there are lots of values. 450 kilo ohm for the base, 430, 410 going down in steps of 20. Then here we have the base current in microampere. Then we have the collector current in milliampere. And of course, if the resistor goes down, then these other two, the base current goes up, and then consequently the collector current goes up. And this is not very friendly for viewing, and I'll put it into a calculation program, and I'll show you the graphical results of this. So this is the graphical representation, and as you see down on the x-axis we have the base current in microampere, not milliampere, microampere. And as I predicted, we go from 9.3 microampere to the left with the base current all the way up to 422 microampere. So a well range of over 400 microampere and 422 microampere, that is 0.4 milliampere. So not quite, we're going not quite up to half a milliampere up here in the base current. And why this is so, we'll see when we later look at the collector current, but I can already tell you that the collector current will be well over 100 milliampere. When you have this base current here of the right of 422 microampere, then you already have a collector current of over 100 milliampere, and 100 milliampere is in the data sheet of the BC547 the maximum rated current you should drive through. So I stopped there. Everything else would be unhealthy for the transistor, in my opinion. And so we're dealing from base currents in this range, and let's look at it. So if we have 9.3 microampere, then we have a beta of 656. So this means that the collector current will be 9.3 microampere times 656. So you get the collector current by multiplying the base current down here with this beta. Okay, and then if we look at the next values here along this blue line, you see we stay well within this range of 660. So sometimes below, sometimes above, but well in that range until then. They're around this 85-ish 85.8 microampere, and after that point we fall down like 50 with beta. Then we end up by 606 once we go to 141.9 microampere. Yeah, and so that's about the deal until 85.8. We have a nearly constant beta of around 660, and then we fall down. And yeah, so this helps you. This can be you can be sure that no matter what base current in that range up to this 85.8, so around 85 microampere, you put it to the base, you can be sure you'll be multiplied with around 660. That's a cool fact about the BC547. But what people often want to know is also at which collector currents we have which beta, and therefore I have drawn a second diagram to which we come now. And now this here, as you look downward, you have here the collector current on the x-axis, and it is in milliampere. So one order of magnitude greater. We're not talking about base current not in microampere, but now collector current and in milliampere now. And as you see, we start out to the left with 6.1 milliampere. That corresponds then, if you remember, to our former 9.3 microampere base current. But we'll leave that behind now, because we just look at it from the perspective of, okay, if I want to drive 6.1 milliampere through the collector, then what is the factor beta then here? And these numbers are the same as we've seen before. Just what you take out of this graph is a different thing. You don't ask yourself the question, okay, how much base current do I drive into the base, and what beta do I get then as a multiplier for this base current? But now you ask yourself the question, you look at it from the perspective, okay, I want to drive so much current through the collector. Let's assume just here we want to drive around 30 milliampere through the collector. You'll see here we have a number 31.6. That is sufficiently close enough. And then you can say, okay, I'll have 661 factor of beta. So this means I want to drive 30 milliampere through the collector. This means my base current will consequently be around 660 times smaller than that on my base. And that's two different angles which you often want to see, like you want to see a transistor. One, okay, I put that current through the base, what do I get at the collector? And otherwise, okay, I want to drive that current through the collector, what will be resulting in the base?
or what do I need at the base? So lots of questions answered from two different perspectives, and both graphs are helpful. But still, the graph's the same, only on the x-axis we replaced the corresponding collector current values to the former base values, so no new insight here from the numbers, just a different view on the topic. And with that, I want to conclude this. I hope you took something out of it, and yeah, I'll keep on doing these videos. If you like them as much as I do, please give me a thumbs up and subscribe. And then up to the next video. Bye bye.